I'm pretty happy to see so many people being excited of talking to me about flexible handling and automation. It was at some points a topic today, but I didn't really see automated systems so far. So maybe I can change this for tonight, and we have some discussions about it with drinks later on. So I'm happy that you share with me the topic of automated textile handling and manipulation for mass customization. I'm Christian, I'm a robotic guy, and I love automation. So I hope I can share a bit of this love with you. And I have to start with excuses and apologies. My first part of my presentation will show my world of automation. So I show something about our innovation and the field where we're coming from, which is logistics, automotive production, and everything. But in the second part, I try to build a bridge to the world of textile production by bringing examples from the supply chain as I see the world of textile production. I hope this gives some insights of our vision and maybe gives us room for some discussion later on. So FORMHAND is a young startup with an innovative and award-winning technology. We're actually a spin-off of Technical University Braunschweig, which is located in Germany between Hanover and Berlin. And we're doing research on our topic since 2011. We were founded in 2017 and already selling since then products, which we'll see later on in the pictures. Coming from research, we have a lot of experiences in different fields, and we understand our technology as a sector-wide, sector-spreading technology. And you're always using FORMHAND technology if you have to move parts from A to B. Different parts from A to B. This could be something you need from the grocery store. These could be car parts, or these could be textile garments or bobbins from the yarn industry, as shown before. And we're very proud of having an own test center in Braunschweig. So whenever you have products which you try to handle and don't know how to, send them over. We make pictures, videos, as you might see later on in our test centers. We have fully equipped robot cells where we can rebuild your processes in a mock-up and to give you an idea what potential might be in automated handling processes in your production. But to start this presentation, I'd like to talk about my motivation, our motivation, maybe the motivation of this whole conference. And I put it like this: individuals' demand for individual products, which drives mass customization. And looking at this, how can mass customization happen? This is, or I'll put it another way, these are customized products which could arise by digital processes. For example, in web shops, we're designing our new car. Change color, change the wheels, change the interior. So I bet you, if we all go to Volkswagen and try to configure our new Scirocco, everyone will have a different car. Same if we go to Nike ID, we design our shoes, make products individual. Or we go to Amazon, put everything in our basket and shop, and then we have many different individual products, namely parcels to ship and to pack. Same with fashion designer homepages, which we have many examples during the day. But this leads to versatile production systems, to versatile warehouse management systems, and versatile and flexible hardware. In my case, it leads to flexible handling systems. And to have another example on this, extreme diversity, I go back to my background, to the car manufacturer. Going back to Volkswagen, here is their main selling product, the Golf 7 at the moment, consists more or less of 6,000 different parts, which are displayed here in this picture. And these parts, for sure, have to be handled during the production process at least once. They have to be transported from A to B. And what happens in industry is that you develop one gripping device, one gripping tool, mainly fitting for each device individual, which means that you have a lot of many different grippers, a lot of hardware in the process, which only is be used for handling one piece from A to B. And this, again, demands for flexible handling systems, versatile production systems. So This is the motivation that drives our vision in FORMHAND, because we say, why do we have to have so many different handling items? Why does it have to be so complex, which comes from this extreme diversity? And we say our mission is to develop handling systems, one for all, to have one gripping solution for many different parts. And here are two examples. On your left-hand side, we have a piping, which is handled by FORMHAND standard gripper R150, which is here in my hand. On the other hand side, you have like the mudguard of this so-called Golf Volkswagen 7. And it doesn't matter if it's the left-hand side or right-hand side of this mudguard. So our vision is to have one gripper for many different objects. But we can drive it further. If you see at the pictures, it's also good for handling your cereal bags, for handling shoes, for handling cartonnage, for handling textiles on the right-hand side. And this is what I'm showing you later on. But how does this working principle work? So I brought a little video. And in this video, you see how a very generic device of FORMHAND works and how it's been handling the tubing, a textile cutout, and the sheet metal from the car manufacturing. In basic state, the FORMHAND cushion can be manipulated and changed in shape. Here you see a cross-section. This is a granular-filled cushion which can adapt to different form shapes. And if we ingest an airstream, the cushion becomes hardened, so every object form can be kept in it, but also objects can be ingested on the bottom side of the gripper, which we can see here. This is handling the tubing, and if you turn off the airflow, we can release the tubing somewhere in place, we can set it into somewhere. But we also can, with the same gripper, without reconfiguration, without changing the gripper, handle a textile cutout, which is porous to air, with a limp, which is flexible, which has sensitive surfaces. And then we can handle a metallic sheet metal and carrying it in the production. So, for all the technical people with us, we have robotic systems, which are pretty much generic. You can use any robot, you can use any handling device, and we can connect our component, the FORMHAND gripper system, to it, which is here, the blue gripper cushion filled with a granular material. It adapts to different shapes, and it can handle different objects with it. We can put it in two standard product categories, which is a round system and a circular shape system. The only difference is they vary in shape and size, so they can handle different objects in objects, geometries, or in weights. So we call these our standards. This is the R150, and this is mainly shown in the later videos and pictures. If you want to, you later can come to me and try on it if you want to. And the other one is FORMHAND E3020. It's this A4 size and similar to your papers on the table. To show you how this actually works in my field of automation, I show you a commissioning process for assembly of cars, mainly of the car back view mirror. What happens, we have to assemble 3 or 4 different parts which are individual for your mirror system. Someone has a mirror system which is electric, someone else has one which has a heating or not. What we saw, the employee puts his tray there, and the robot knows, well, I have to assemble the left-hand side mirror for Red Scirocco, and puts in the bag with a cable system, pulls from the stock the box where it takes out the case of the mirror, puts back the box, and gets the mirror itself and puts it in a tray. So the employee can take the tray to the assembly place and assemble the mirror. Very important is to understand that FORMHAND not only handles the objects, but also makes the process at all possible, since we're also handling the logistic goods as the cases and the bags where the material or the objects are carried with. So we can rethink a whole process, not having lots of infrastructure around it, but just setting up the robot and the gripper which adjusts itself to different object sizes object geometries. And you see here in this picture, we have handled 3 different objects and the box with 1 gripper without changing the gripper and without reconfiguration. So to put it in a nutshell, FORMHAND offers form flexible shape gripping. We have an easy integration with the system. We have efficiency right away since we use very efficient energy airflow production systems, airflow generators, and we reduce the number of grippers in production massively. The system is modular and scalable. We allow for gentle gripping, which will be a main driver in the textile production, as we show later on. And we can use it in a multifunctional way, since it could be used as a clamping, as a holding, or as a storage device as well. So, as I promised, I now try to build the bridge from this to the world of textile production. And from my point of view, we have a supply chain which looks pretty much like this, which we can, from my point of view, put into 3 steps. The first steps would be material production, everything from raw material, raw fibers, to a processed fabric, which we can work with. Then we have, from my point of view, a manufacturing process where we do the patterns, the cuttings, where we end up with the finished good. And then everything comes with logistics, where we have distribution, quality check, packaging of material, which from my point of view is pretty much the same as in other industry sectors. It's just about moving parts from A to B. So what I like to do in the second half of my talk, I try to give examples how we from FORMHAND think we can do automation in these areas. So let's start out with material production. In material production, we have sensitive and limp materials, such as fabrics. And what is a big challenge for handling systems, this material is porous to air. So usually, suction grippers do not work. We changed a little bit in the working principle. We have a high airflow generator system, so we can grip these objects, as I will show later on. And we don't have to use needle grippers, which ingest into the objects. We don't do any harm to the objects. And we can transport textile fiber cutouts in the flat state, so we can transform them from A to B without wrinklings, crinklings, or any change in shape. This is a video taken from this year's text process, where we went with this robot. And here, after another, the same gripper again shows handling this bobbin, this roll of fabric, and later on the small baby t-shirt, which is folded in an 8-layer stack. It can be handled right away. And this process went through 800 times a day, 4 days a week. So this is like an automated process we mean when speaking, doing automation and handling. Here again, this is this gripper handling this model of a textile fabric roll. Sorry for not knowing the exact words in your word, but this is what we understand with this. And I said it's scalable. The system, if we have a full-scale roll of fabrics, we would use either bigger gripper or use 2 of these in line to handle this. But also the bobbin, as you saw it in the picture, can be handled either with different diameters, with different sizes, of course, with different colors, but this is not that challenging, of course. For example, putting it into the sewing machine or taking it out. If we changed color, sometimes we have different diameters of these, so this is where we come to gentle and flexible handling for production. Going to manufacturing, we now have like our processed fabric. We do the patterns. It's nothing we can automate from our point of view, but after cutout, we can transport objects. And as we saw in the picture before, in the video before, we can transport the finished goods, the finished t-shirts, for example. So we are confronted with cutouts in different sizes and shapes. And what I experience from talking to people and talking to people on tech process, we still have a very humanized production. In the speech before, we heard about we're still somewhere in the point of Industry 2.0. Having these pictures in mind, we have sewing processes, at least sewing processes where at most people and humans are in contact with handling solutions. And it's also happening If you're only just carrying the cutouts towards the sewing machine, then we have these contact situations where robots, cobots, or handling systems come in contact with. This is something I like to show an impression on. Here is what I promised. This is the square-shaped FORMHAND gripper, gripping 2 cutouts from a modelized cutting table. These cutouts are flatly handled and can be carried from A to B. So what I saw at Text Process, we have many cutting tables fully automated, and from controlling these systems, we already know where the pieces are, so it's very easy to actually locate them and to take them and to have some collection, some manufacturing or some assembly prepared for the sewing people. So putting these parts in the right order into a bag and put it to the sewing machine would be an easy way to make an automation here. Or handling and manipulating fabrics on such a system. Remembering the principal video from the start, we can pick up textiles in flat position. The textile is gripped on the surface of the gripping cushion. The gripping cushion is hardened by an airstream, but we also can make it softer again, so we can do manipulation of this glass fiber textile cutout. This is what I'm going to show you in 2 ways later in this video following the slide. On the first, it's automated in addition with a manual process, so it's a cooperation of human and robot, and afterwards it's fully automated. In this video, we're using a KUKA IVA robot, which is fully certified for human cooperation. And in the back, you see this textile cutout in the magazine. In the middle, the blue gripper system, which picks up the textile, brings it to the preforming station or the draping station. The human teaches the process of doing it, and the robot can redo it ever and ever again. This is like a modelized process for manipulating a textile. But it can fully automate, work automated as well by using a big robot, picking up, doing the draping. This is happening by changing the stiffness of the gripper cushion, picking up it again, and replacing the textile somewhere else, either in shape or in flat. This also could be used for gluing 2 surfaces onto each other, or for pressing textiles, whatsoever could be their thought in production process. And you see, we can keep the shape. This is something we experience from other production lines where it comes to carbon fiber reinforced plastics. When we have textile cutouts such as glass fibers, or in this pictures carbon fibers, taking them from the cutter table and put them into the shape of the mudguard, which is later on injected by resin to come to a carbon reinforced plastic part. And the last example is coming from these logistics. Maybe they are most likely to the processes I already know from car production or logistics in groceries. We have all this checking done, but then we do some packaging, doing the shirt into a plastic bag, carrying the plastic bag to the stock, taking from the stock, putting it in the cartridge to send it over to our customers in delivery and dispatching. So what we have here is, of course, we have sensitive goods, sensitive products, since we talk about the final product which actually we wanted to sell. We have many different shapes. If you think of garments at the one hand, but we have apparels and shoes on the other hand, so we have to handle different shapes and objects again. And we have different kind of packages, since it might be packed in bags or it might be packed in boxes. And again, I start out with the video now. It's about handling shoes with this very same gripper again. And this is about, from my point of view, picking up shoes at the final stage and packing them. This is in cooperation with the German producer. We have these shoes. The robot gripper cushion adapts itself to its shape, can handle this very ergonomic shape, transport the shoe, pick up the shoes together as they would fit into the box later on. I'll pick them up with the wrapping. They come and are going to be shipped to the customer, put them in the bag, in the box, and of course, again, carry the whole box in a packed state and put it in the shelf for storing where it's waiting to be shipped later on to the customer. Well, this might be interesting detail. You see very much how the gripper cushion itself adapts to the shape of the object without harming it, with making it handable, even though if the shoe lies a little bit slightly in angle, or you can grip it the other way around, this is no problem. But also handling a packed item. Last time when I ordered with Amazon, my shirts came all in big plastic bags. These have to be handled. These also have to be packed, which is possible with our handling system. And the manipulation of textiles, which I can drive for many ideas. It could be also a sticker which is applied somewhere. This could be a label tag to the box, which are sent in the end of the logistics supply chain. Well, with this textile picture, I'd like to finish my talk. Thank you for your attention on this last very speech. I'm very happy to answer your questions and to fulfill your orders. Thank you very much.
Any questions from the audience? Just 1 second.
If I understand you right, that you have right now you have developed 2 grippers, but the principle is principally it's the same.
It's totally the same.
So you can also have smaller grippers or bigger ones.
Of course, we call them standards since we have to start out with a product
somewhere
to make pricing, to make ideas. These 2 sizes I presented are working for most of the goods we know from the other world. I think in this area the square shape would work very well, but he has already siblings which are 80 diameters. The big one has siblings which are 3-4 times as big as shown in the picture. So it's about the technology, having an airstream in combination with a granular filled cushion, which can be scaled, which can be used as a modular system, right?
No, okay, thank you.
Two questions. Is it do you have zonal control of the gripper, or is it just the entire surface?
We have control of what? Of
the zones. Is the gripper broken into zones, or is it one gripper?
Yeah, these are modules which are always gripping in the whole area. We can, of course, change the layout of the gripping area, but what happens, we use it as modular systems. So if you have smaller parts, we can combine them to an aerial gripper where we, of course, then control different section areas. For example, in cutouts in a table, if we have a cutter table, we take parts of it. We have grippers like 4 in a row, and we can handle big parts with all 4 of them and turn off 2 if you know it's smaller parts. It's pretty easy, since from the cutter layout we already know where the parts are. So it's for robotics no challenge.
And for textiles, have you tested it on different textiles? Different materials?
Yeah.
Like,
so we also can pick up non-wovens. We can handle different kind of carpets. If the textiles become more heavy, as in carpets, we have to increase the area that is covered.
How about lighter?
So we have to find, at some points, we have to find like a compromise about it. But it works very well.
And any issues with poly, like polyester or lightweight fabrics?
Not that I know of.
Okay.
So,
thanks.
If you're interested, later on I have some more videos which show these details.
Any other question? Okay, I think you're around for the drinks reception as well. So
Yeah.
if anyone's got a question, please feel free to have a chat with Christian. Thank you so much.
Thank you.
And,